Yeah, Simra and Neha, am I audible to both of you?
Yes, ma'am. Good evening, ma'am.
Good evening. So yes, we're having a class after a long time, no? In between we had the Eid break. So last assignment was dot product. Resolution of vectors you both were able to attempt quite easily. In the dot product, I think a little trouble was there in the last part. So I have your assignments with me. This was Neha's assignment. Yeah, Simra, one thing. In the first question, there was a small calculation mistake that just led your answer incorrect. Square of 2, you have written it as 2. Okay? So that will just change your answer. That will make it as root 4, which is 2. So here the problem was, otherwise the method was correct. There was no problem with the method. Okay? Then Neha's first, second, third, fourth. Okay, fifth and sixth were the doubts. Yeah, yes, I remember. And fifth and sixth. This we discussed in the parallelogram law also, a plus b whole square. So I have written the solution for sixth one in Simra's notebook. So I'll show you from there only. See, fifth one, when your a vector plus b vector is magnitude is equal to a vectors minus b vectors magnitude. Okay. In the fifth question we have. So look here. I think I wrote in Simra's. Yeah, this was right. And yeah, I have written it here. See, fifth question, let me discuss it from her notebook only. See, when you have a plus b and a minus b correct, Neha, this one is for you. When you square both the sides, you have to find out the angles. Now, you know the magnitude is missing. You can apply this also or straight away without this also if you want. What you can do is you can write the values of the vector. How do you write the magnitude of the vector? You write the magnitude of the vector as a square plus b square plus 2ab cos theta under root. For the negative, same thing you will write. Okay. Now, when you open, if you remember for plus and minus, how do we write? Eventually, for the positive and the negative one, how do we write? If you have the positive vector and the negative vector, isn't we already know how do we? Just a second. Yeah. So when you know the magnitude of A, magnitude of B, finally what we do, we add and subtract. We know we are going to add. We know how we have to add the two vectors and when we will subtract them. So one thing is the method which Simra did. That's also completely correct. You can follow this. Square both of them. Square A and square the vector B. You square this side, you square this side. Okay. So A square will be cancelled. This is basically A square what we have. A square on this side, A square plus 2AB plus B square. This you're opening up the identity. Same thing you're doing it here. Okay. Now when you add both of it will give you 0 here. Now, one thing which I wanted to say to you, Simra, was if you take this one, no, here your angle is missing. What you can do, you can directly take the angle. Like take the angles in the sense when you have a plus b. You know, same thing, a square plus b square plus 2ab cos theta with you under root. And this side you take a square plus b square minus 2ab cos theta with you. Now, when you square all the term, this will be a square plus b square plus 2ab cos theta. This side will be a square plus b square minus 2ab cos theta. A square, b square will be cancelled. Bring this on this side. 4ab cos theta will be 0. Right? 4ab is getting divided here. Cos theta is 0. Theta is 90 degrees. Yeah? So here your angle will be preserved. Okay? This is one thing that you can do. Got it, Neha? Now have you understood this?
Yes.
Okay, this I think you will be able to write. Let me tell you this one. See, it says unit vector A, unit vector B inclined at theta angle. Here the problem with this question was a trigonometric identity had to be applied. That's why this question became difficult, which I wrote in your paper, Simra. See, here, this is the solution to this question. You take both the vectors magnitude and you square it. What the question said? The question said a minus b. Correct? The question has said to take a minus b. So we'll also take a minus b and we'll square it. Okay? What is written on the other side? We have to prove it. We have to get 2 sine theta by 2 somehow. This is what we need to get. So what do we have here? A minus b whole square is what we need to get. What do you do? A minus b whole square is an identity whose value is 1 minus cos theta, which is equal to 2 sine square theta by 2. Okay. So when you take the root value of this, you directly get 2 sine theta by 2. You just have the theta over here. Got it? This is under root. This is a vector, unit vector minus b unit vector. This is what you need to get. The vector, there is a trigonometric identity. See, what is this equal to? This can be written as 1 minus cos theta. Do you agree? How? If you take under root of 1, what's the magnitude of a cap? 1? Yeah? What's the magnitude of b? 1? 2 into 1 plus 1. Right? 1, sorry, not 1 plus 1. Sorry, 2 into 1 into 1. A under root, I'm using parallelogram law class. A minus b vector when we have, how do we write them? This is how we write them. Cos theta. So this will become 1 minus cos theta when you take the common. The identity, trigonometric identity is 1 minus cos theta is equal to 2 sine square theta by 2. So this is whole square. Remember, a cap minus cap whole square is equal to 2 sine square theta by 2. Okay. So then when you take the root of it, this becomes sine theta by 2. So Simra, I've written it in your paper. Neha, you copy it. Simra, you'll find it in your assignment directly. Neha, you just copy, then we'll start with cross product.
Done, ma'am.
See class, we have completed with this segment. The dot product part we have completed. Now we have to start with cross product, and we were on the properties of cross product, I remember. Just tell me one thing, have you all written the properties of cross product, or were did we discuss it? Just check it in your register. Have you all written till the third property?
Yes, ma'am.
Yeah, Simra, you also? Okay. Let's discuss the fourth property, which I wanted to discuss with you. Remember, in dot product, I told you that when you have perpendicular one, I dot j, j dot k, what is it equal to? Perpendicular vectors in the dot product. I dot j, j dot k. See, recall it with the angle. What's the angle? What's the value? Do you use cos or sine in dot? An angle between all the three, I cap, j cap, k cap will be 90. So cos 90 is 0.
Zero.
Yeah. So I cap, k cap, j cap, if you take their multiplication, that will be 0 there. But it won't be in this case, in the perpendicular vectors one. See, there's a very good technique. If you understand this, you'll be able to remember this throughout. What you do, just mark I cap, j cap, and k cap in the corner of your register somewhere, like this. I cap, j cap, k cap in this triangular form. And then what you do, start going clockwise. Okay, let's go clockwise. If I say I cross j, it will give me the third leftover quantity, which is k cap. Okay. If I go j cap, just move clockwise. J cap cross k cap. It will give me the third left quantity. J cap cross k cap will give me I cap. K cap cross I cap. It will give me J cap. Whichever is the left one, no, write it. Now for the sign, if it is clockwise, are we moving clockwise? Yeah, we moved clockwise. So it will be positive. Means I cross j gives you plus k cap, j cap cross k cap gives you plus I cap, k cap cross I cap gives you plus j cap. So instead of remembering this, do this. You don't have to remember. I still don't remember it like this. I always do this till now. Like this is very helpful. Just draw I cap, j cap, k cap. Okay, I cross j, it will give you k. K cross I, it will give you plus j. Okay, like this. Now, if you move anti-clockwise, just opposite. J cross I. What is the third one? K cap. I cross K cap. What's the third one? J cap. K cap cross J cap. It will give you what's the third one? I cap. But we moved anti-clockwise, so it will be negative. So J cross I gives you minus K cap and I cap cross J cap gives you plus K cap. This cannot be changed. You have to remember it as it is. Okay, so the best technique is that don't just mug it up. You will forget. बिल्कुल भूल जाओगे कौन सा वाला किसका था, प्लस कहाँ आना था, माइनस कहाँ पे आना था. You will just forget it. So for that, just draw I cap, J cap, K cap. If I ask you K cross J, okay, K cross J anti-clockwise, so minus I cap, like this. You can remember. Or if I ask you, let's say I cap cross K cap. Okay, I cap cross K cap like this. You imagine IJK, I cap cross K cap. So you are moving anti-clockwise, so it will be minus. What is left? What is not given? J cap. So minus J cap. Let's say I cap cross J cap. Okay, we are moving clockwise, so positive. What's not given? K cap, so plus K cap. I think like this, it will be better. You'll be able to remember this. This is the fourth property. Okay. And now solving part is left in Cartesian form. This sine theta, I have already told you, AB sine theta. We'll practice questions on all of it, but I'll tell you the Cartesian form one. This is a little different. It's not simple like dot product. Dot product was very easy, just multiply. Like coefficients, multiply all of it. Write down this fourth point, then I'll discuss the Cartesian form with you. Simra, you have also completed?
Yes, ma'am, done.
Okay. Let's see how we actually solve it in Cartesian form. Now see, you have to remember the coefficients. I cap has the coefficient 3 here, I cap has the coefficient 1 here. Now remember, I told you that cross product is anti-commutative. You cannot change it. Like if it is given A cross B, you have to write it as A cross B. You cannot make it as B cross A. So here, R is given, F is given. Let's say we have to calculate R cross F. Okay, this is actually a quantity which is known as tau, that is torque, the rotational force that you will study in the rotational chapter. R cross F is there. Now what you do, which one is the first vector? First you have to draw a determinant system. How do we do that? Write I cap, write J cap, write K cap. Okay. We have to now fill this. How do we fill it? Write down the coefficients of the first one as it is. Okay. R is there. Coefficient of I cap is 3. So I'll put 3 here. Coefficient of J cap. First I'm writing for R. So coefficient of J cap is 2. I'll put a 2 here. Then coefficient of K cap is 1. I'll put a 1 here. Okay. 3, 2, 1 from here. I cap, J cap and K cap. Clear? Now, next vector is force F. Let's look at its coefficient. I cap is 1. J cap is not given. So it is 0. K cap is 3. We have just put the vectors. We have them listed them. It's clear till here?
Yes, ma'am.
Okay. See, now how do we write it? Let's say we have to write R cross F. For I cap, what we'll do? For I cap, just cut I cap completely. Cut the row, cut the column. What are you left with? These 4, right? You are left with this, this, and this. Correct? You have cut the column and row of I cap. So what are we left with? These 4. Now you need to move vertically down like this, diagonally down minus diagonally up. That is 2 multiplied to 3 2 into 3 minus 0 into 1. This will make the coefficient for your I cap. What did we do? We cut I cap completely. It's row, it's column. We are writing I cap. So we are cutting I cap only. What did we do? 2 into 3 minus 0 into 1. You're moving down first, then up. Product of the numbers diagonally down minus the product of numbers vertically up. This is how you will go like this, then you will multiply them like this, and these have to be multiplied. These are the products. Okay, this much is clear. Now let's come to J cap. We have to write J cap also. J cap means just put a minus J cap, because if you put a plus J cap, then you'll have to do this calculation. Lots of techniques are there for J cap. You have to reverse it, multiply it, and also it's better, why not to put just a negative sign and let the other things remain as it is. So minus J cap. Okay, there are lots of things. Lots of steps have been now put. Okay, so minus J cap. So what we'll do? Cut J cap completely. Okay. Then what was our step? We move diagonally down, right? So these 2 will be multiplied. 3 multiplied to 3. So I'll write first 3 into 3 minus, what do we do next? This one. We go like this, right? 1 into 1 minus 1 into 1. J cap is clear? Okay, it will be a little confusing initially, but with practice only. I told you cross product is not simple like the dot one. Okay, dot one was very easy. Just multiply the coefficients, answer is done. Here lots of things you have to take in, and the biggest problem with this that you cannot change any order. Whatever are the steps, just follow them as it is. Okay, let's come to K cap. For K cap, I'll cut this, I'll cut this. But for K cap, you don't have to put a minus or plus, just write normally the way we write I cap. I cap and K cap will be plus, J cap may minus kar dena, so that your steps are uniform. So at least you have to remember less things. If you write J cap as positive, then there are changes here. It's better remember one thing, just put a negative sign in the J cap. Now what do we do? 3 into 0. Right? We multiply. See, first check what are you left with? You are left with these 4. Then you go vertically down, multiply them. So 3 into 0 minus, what do you have? Go like this. That is 1 into, this is how you have to write the entire one. Now you are just writing the coefficients. 2 into 3 is 6. Minus 0 into 1 is 0. 6 minus 0 I cap. 3 into 3 is 9. Minus 1 into 1 is 1. Minus 1. Here minus j cap. Okay, minus j cap, same thing. Then here plus 3 into 0 is 0. 2 into 1 is 2. So minus 2 k cap. What's the final answer? 6 I cap. 9 minus 1 is 8, but you have minus. So minus 8 j cap minus 2 k cap. Did you understand this, both of you? Simran, Neha?
Yes, ma'am.
Yes, ma'am.
Write it, we'll practice more questions. This part is a little tough. See, this one was very easy. You'll be able to do this. A, B, sine theta is similar. But write it, we'll practice first. Write it down. See the geometrical meaning of cross product. Then we'll practice some more questions. This is vector A, this is vector B. Okay. Sometimes you are asked to write the area of the parallelogram. Remember, area of parallelogram is vector A and vector B is magnitude. Means you have to take the cross product and the magnitude of them. That's why I've highlighted the magnitude. And if you are asked to write the area of triangle, then take the area of, or just take the cross product magnitude and divide it by 2. This has been asked a lot in the exam, area of parallelogram and area of triangle. Okay. See, then try this question. First, unit vector we have already studied. We'll discuss it quickly. But first, write it down. Then let's practice now questions based on cross product. Okay, class. So this says find a unit vector perpendicular to both A and B. If the question says perpendicular, you need to get the dot product. If the question says unit vector is parallel, then how will you calculate the cross product? Okay, now see, this is you have to get the unit vector which is perpendicular to both A and B. So how will we calculate? Have you calculated? Are you both doing it? Did you get any answers?
Not yet, ma'am.
Not yet. See, when two vectors are parallel, in that case, your what we say, the cross product, they'll be zero. That's what we've studied because you have sign element here. Right, class? And when you have sign element, what does it mean? In a sign element, you have the value of vector 0. I think we discussed it in the property. Yeah. See, I dot I, j dot j, k dot k. So if the question says parallel vectors, it means your answer is 0. So it means when you take the cross product of them, the answer you can equate it with 0. Like in dot product, if they were perpendicular, we were equating it with them with 0. But in perpendicular, we have to find a unit vector which is perpendicular to both of them. That will give you a value. If I started and solve it with the help of cross product, how will I get it? I'll have to first take the cross product of it. So for unit vector, perpendicular means if it is parallel and I'm solving it with cross product, just have this in your mind. That will just simplify it. See, parallel in case of cross product, the resultant should be 0. Okay. And parallel in case of dot product will not be 0. I dot I is 1, j dot j is 1, k cap dot k cap is 1. Whereas parallel vectors in cross product is I dot I, j dot j, k dot k is 0. So if question says prove that these two vectors are parallel, or if these two vectors are parallel, find their resultant. Use simply cross product because you know the resultant will be 0. And if you have perpendicular, then see you are getting some value here. Whatever is it, like we are just taking the final unit vectors, but you will have certain values. So here also we are going to take A cross B and then we'll take its unit vector. Because perpendicular, if I take the dot product, it means it will be 0. How will you choose? Like right now we are studying cross product, so this is obvious that the question is based on cross product. But how will you identify, is the question, do you need to apply dot product and cross product? You check perpendicular. Okay, two possibilities are there. You can solve it using dot product, you can solve it using cross product. If it is dot product, in dot product you use cos theta, in cross product you use sin theta. Initially when you are practicing as beginners, you can learn it like this. Once you have practiced and you are practicing for your final exam, you will be able to write it directly. Okay, so dot product you have cos theta, cross product you have sin theta. Now if I have perpendicular, perpendicular means cos 90 is 0 and perpendicular sin 90 is 1, means I will have some Class, am I audible now?
Yes, ma'am.
Are you able to see the screen?
Yes, ma'am.
Till where were you able to hear before my internet went off?
That sin theta, sin 90 is 1.
Sine
And then,
90 is 1. Okay, then you were not able to hear. See. Dot product, in dot product, when we take the dot product, cos theta comes and cos theta is 0. Okay, so when you want to find out something that is missing within the vectors, you go for dot product because you know the resultant is 0 and you will be able to get the resultant, right? You will be able to form an equation. But when you want to find out a new quantity, the resultant, if I go with dot product, answer will be 0. So which should we prefer out of dot and cross? We will prefer cross product here because we need to calculate something which is non-zero. We have to find out something. When we want to find out something missing and equate it to 0, we can go for dot product. This part is clear. Which one to choose?
Yes,
ma'am,
ma'am.
can you explain again?
Yes, Indra?
Can you explain again?
Yes, I'll explain it again. See, if you have, let's say, I yes, I was saying if you have something like, I don't know how with the vectors are perpendicular. What can I do? I have two vectors. We take the dot product A dot B. It will be 0 because cos 90 is 0. So what should we prefer in such a case? In such a case, we dot product. Simra, this one
Yes,
which
ma'am.
I said.
Yes, ma'am.
Now see, suppose this is not the question. Question is two vectors are given whose resultant we need to get and they are perpendicular. Look here like this. 0 here. Why cross product? Because your sine theta sine 90 will be equal to 1. And if I choose dot product, directly cos 90, that is 0. I'll get the answer 0 here. I'll never be able to get the result. So in such a case, you should prefer cross product. Now is that clear?
Yes, ma'am. Clear.
Okay, so we'll take the cross product here, the resultant, and we'll calculate its unit vector. See, we have to find out A cross B. Let's make the determinant system. I cap, J cap, K cap. First vector 1. Second vector j cap 1. Third vector minus 2. Then, I mean, I hope you're understanding. When I say vector, I meant unit vectors. I cap, j cap, k cap. Now let's come to B. What is this? This is also 1. What is the j cap's coefficient? Minus 1. What is k cap's coefficient? Minus 3. This part, if I'm able to write, I should go for A cross B's resultant. First, we cut the row and column of I cap. We go 1 into minus 3 plus then we go minus 1 into minus 2, right? Minus 1 into minus 2. What is this? This whole is the I cap. Now we have to write j cap. So for j cap, what do? You eliminate j cap completely, right? We'll eliminate j cap completely. So we'll be left with minus, for j cap we put a minus, 1 into minus 3. Look, this 1 into minus 3. 1 into minus 3. Minus 1 into minus 2. Like this we go. Then we go like this. 1 into minus 2. What was this? J cap. I've already put the minus sign here. Then let's come to K cap. We cut this, we go like this, then we go like this, right? So for K cap, I'll have plus 1 into minus 1 minus 1 into 1. This is K cap. Now see, what am I left with? What is my A cross B equal to? Minus 3 into 1 is minus 3. Minus 1 into minus 2 is 2. But here we have a minus sign. I cap. Just correct me if I write something wrong. Then you have 1 into minus 3, that is minus 3. Minus 2 into 1 is minus 2. But there's a minus j cap here. 1 into minus 1 is minus 1. 1 into 1 is 1 with this negative sign, minus 1 k cap. Now class, can I write the resultant as minus 5 I cap? See, this is minus 5, that becomes minus, and this minus 5. So what will it be? See, minus 3, sorry, this is minus 3, this is minus of, okay, this is minus of minus 2, no? So it will be plus 2. So 2 minus 3 is minus 1, and minus 1 becomes plus j cap. And minus 1 minus 2 is minus 2 k cap. So what is this? This is A cross B. But do we need this? Is this our answer? Unit vector to perpendicular to this means you have to make its unit vector. Let's say this is the resultant. So resultant's unit vector will be vector as it is divided by its magnitude. So first, for that, we need to find out the magnitude of it. What will be the magnitude? Minus 5 whole square plus 1 whole square plus minus 2 whole square. So what is this equal to? 25 plus 1 plus 4, which is equal to root 30. Is this the magnitude? Now see, what should be my R cap? Vector divided by its magnitude. What's our vector? Minus 5I cap plus j cap minus 2k cap. Divided by what? Divided by root 30. Is this clear? First part, is it clear?
Yes, ma'am, clear.
Okay, Neha, you've understood? Okay, you see, we have just calculated the cross product resultant, and then we have taken its unit vector. I'll make you practice more questions on this. It says area of the parallelogram having AB as adjacent sides. We have seen what is area of parallelogram. You just take the magnitude of A and B. Correct? So second, this is your first part. Second part will be area of parallelogram. It is A cross B's magnitude. I think we have already calculated that. A cross B was this. Its magnitude was root 30. So this is root 30 unit square. I hope I'm clear till here. Any queries, Neha and Simra? Anything you want to ask? Clear properly?
Yes, ma'am. Clear.
Okay, write down the solution. We'll practice some more questions from this because cross product needs practice. One question I'll give you. You try that, then we'll discuss. Class, tell me the answer to this. A vector is there, B vector is there. Find A cross B, both of you. Okay, both of you have given the answer. 3 I cap minus 5 J cap plus 2 cap. Correct. One more question I'm giving you. Yes, correct, Neha. Your answer is right. Simra, are you reaching towards the conclusion?
Uh, yes, I just got my answer, but I'm not sure.
Okay, just share it with me.
I got 33 units square.
Yes, that's correct. 33 unit square. Okay. 33 unit square is the answer. That's right. Okay, one more question is there which is important. Calculate the angle between the two sides of a parallelogram parallelogram when its area is AB by. See how to solve this question. You have to find out the angle between two vectors, basically the sides of parallelogram, when the area is given as AB by 2. So we know when do we have the area? It's A cross B's magnitude. Basically, area of the parallelogram is A vector cross B vector and its magnitude. Now, we know one thing, A cross B is equal to magnitude of A, magnitude of B into sine theta. And this magnitude part has already been given to us. Area is AB by 2. So if you put this as AB by 2, which is AB sine theta, AB will be cancelled. Sine theta is equal to half. What is theta? 30 degree. So between A and B, this is vector A, this is vector B. The angle is 30. Okay. Please write down this third question. Look here, class. This says if you have to find out A dot B if magnitude of A is 2, B is 5, and A cross B is 8. See, if you write A cross B's magnitude, okay, if you are writing A cross B's magnitude and you're adding, means you're adding dot product and cross product. Remember, this is very important. We have not done this before. If you have A cross B and you're adding it to A dot B, okay, look what we'll get. This is one thing just tell you here, magnitude of A, magnitude of B, or let's take the square of it. Directly we'll get the answer. If I am adding the square of their magnitudes, okay, cross and dot. Now look, how will we write this? Square of A, square of B, right? That's how we take, and what do we write? Sine square theta here. Yes? Class, tell me here, if I write for A cross B square, will it be A square, B square, sine square theta?
Yes, ma'am.
Yes, ma'am.
Similarly for dot product B, tell me for this, what will I get here in polar form?
A square, B square, cos square theta.
Plus A square, B square, cos square theta. Class, if I take A square, B square common, I'll be left with sine square theta plus cos square theta. What is this equal to?
1.
1.
1. Yes. So from here we can say A cross B's magnitude whole square plus A dot B's whole square is simply A square, magnitude of A square, B square. Put in the values. This is 8 square plus this whole term is missing. This is 5 and 2, square of 2, square of 5. So when you solve this, this is 25, this is 4, this is 64, right? So this will be subtracted. Look, 64 plus A dot B whole square is 25 into 4, which is 100. So A dot B is 36 whole square, sorry. So what is A dot B? Plus minus 6. Clear?
Yes, ma'am.
Yes,
Now tell me, Simra and Neha, one thing. Is dot product and cross product, are dot product and cross product completely clear to both of you?
Yes, ma'am. Clear.
All right, please write it down. Now tomorrow I'll do angular projection. Please write it quickly, just let me know done.